welcome. This is a talk about how to replicate MySQL data to TiDB database. Anyone familiar here with TiDB? Just you a little bit? Yeah, I know. You tested, but yeah, okay.
I heard.
Okay. I'm going to introduce myself first. This is me. I'm a Percona architect, and I'm a microbrewer that likes to share some time with the little one of the family. She loves to serve beer, so I think she's missing already. Okay. So, what is TiDB? TiDB is a distributed, storage distributed hybrid database. And by hybrid, they like to say that this is both prepared for analytic and transactional workloads. So this is kind of hybrid. The architecture of the database internally is quite complex. It's I would say it's a kind of beast because it's a lot of moving pieces here. So this is a high-level overview of the components. Reviewing each of them, we will find that we have the TiDB cluster. Okay, this is we can call it the API that will face the applications and will communicate all the processing against the rest of the components in the cluster. This is responsible for getting the connection from the application side, process SQL, whatever it means, a query, and send the message to the rest of the cluster, and then communicate back the answer to the applications. So this is the first layer and the only layer that the application will actually check or connect to. Then we have the PD cluster, which stands for placement driver. Basically, this is the component of the cluster that will hold all the metadata, will control what is happening inside the cluster or with the storage. It is responsible for not only storing metadata about the status and the components and how everything is working in the cluster, but also it will be responsible for handling the data internally, how the data is sharded, how the data is stored, how the data is balanced among all the nodes in the storage side. There are some other responsibilities, but basically it's about that. And the last component, there's a fourth that I on purpose excluded from the talk because it's something different from this. The third component is the TiDB, the distributed storage. It stands for TiDB. The Ti stands for titanium. Stands for titanium, and in this case, it's Ti because it's titanium key value store cluster. RocksDB underneath is a distributed RocksDB database. Everything is based on key value storage. So the data, when it comes here, is already parsed and recreated to be distributed in key value stores. So one of the things that the product is claiming that it's fully MySQL compatible. It is partially true. It accepts and talks the MySQL protocol, so you can connect to TiDB using the MySQL client, no problem with that. It will accept almost all DML's commands, and almost, it's fair to say almost all DDL commands. There are some limitations, of course. It doesn't support views, it doesn't support triggers, it doesn't support store procedures like MySQL does. There are a few other limitations, but all in all, it's quite easy to start querying the DB. You just connect with a regular MySQL client, it exposes a different port, but that's it. And you create a table, you query, you insert, you select, like you do in MySQL. So it's pretty much compatible in that regard. Some of the things that you will read is that in the documentation is like you may not need to modify your application. And well, if you happen to find the guys from booking here, ask them, and they will say no, it doesn't work like that. But yeah, it's pretty much compatible. So the talk is about replication, how to replicate from MySQL to TiDB. we consider few goals when we talk about replication. Number one is about consistency. What if we lose communication with MySQL? What about the data coming to the TiDB? We need to make sure that everything works in terms of the data. If we lose communication, okay, can we resume? If we have data inserted, can we make sure that the data is correct compared with what is in the MySQL server? And we consider performance reasons, like what happens if we have replication lag. Is avoidable? It is a problem with TiDB. It's a problem with the way that you are querying MySQL actually creating data there. And finally, about observability. How we know that the process is actually working, right? If the process is broken, I mean, we need to make sure that there are a way to monitor if the process is working. For this matter, the product has a bunch of tools. They are present in the distribution. You can download them. They are open source. And basically, we have some known tools and some others that are created by them. The first thing to create replication stream from TiDB to MySQL is using mydumper, loader, and syncer. This is the first one is pretty much the same version. I will talk about that of the regular mydumper. If you are familiar with that, it's pretty much the same. Loader instead is a new tool that is a kind of implementation of MyLoader but in Go. And finally, we have syncer, which is the responsible to keep the cluster up to date with the data. Somehow, they created a new tool that encapsulates all the functionality of the first tree called data migration, which has some internal tools and some extra moving pieces in the whole puzzle. But it's a combination of the other one. Then they have this tool, TiDB Lighting, which is a loader that works super fast. So it helps to load a bunch of data in really quick time. And finally, as we said, it speaks the MySQL protocol, so you can do it yourself. It's not a big deal. Maybe it's hard to keep everything up to date in real time, but aside from that, is something that you can create. You know, do a load, select it to alpha, and then pipe the output to the MySQL client, and then we load the data in TiDB. So, mydumper. As mentioned, whoever is familiar with the tool, you can see that the command is pretty much what you will use in with MySQL. The only restriction it has is that it is not capable to read compressed backups, so you have to uncompress all the data. And they added a new optimization. I'm really pointing here. They have an optimization, actually a customization, because when you want to dump the data from TiDB, you can instruct mydumper to set up a flag, which is to take consistent backups without doing flush tables with gridlock. It's a functionality that is present in TiDB, not in MySQL. The rest of the tool is pretty much the same. Loader is the component that will load the data into TiDB. It is highly optimized for make things fast. It can work in parallel. As mentioned, it only understands uncompressed dumps, but it can use two different types of dumps. Logical dump from MySQL or CSV files. It can parse CSV files pretty at the same time. Yes, Marco?
Can you uncompress and pipe directly, so on the fly?
Yeah.
Okay.
Yeah, the only thing is that you cannot instruct loader to read a compressed file as you can do in MyLoader.
Okay, so but you can pipe it?
Yep.
Yeah, okay.
Yep. Yeah, as long as the stream is uncompressed.
Okay.
You can use MyLoader to insert the data if you want to use compressed, but there are some restrictions. Number one, you have to use my loader with the transaction size equal to 1, so everything is a single query. My loader is not resumable, so if the process fails, you have to start over. Which in loader, there is a control that will keep track of what changes have done, so if the process fails, you can resume from the last checkpoint. And there is an interesting thing that you can do some kind of filtering on the fly. So you can instruct to say, okay, from this backup, only load these tables, and it will work. This is a sample of configuration file. Nothing too fancy aside of the regular things like low level and low file, etc. But then you have where this is okay. There is a checkpoint schema where it will store the data and the progress of the load. You can instruct the tool to how to do that, and then you have these things that are variables that you can configure to force some bin logging of the transactions that are happening, filter rules, ignore some commands to avoid doing that, pushing that into the binary log. They have their own binary log. I'm not sure exactly how it works, so I'm pretty new on this, but it has an analog of MySQL Binlog, so at some point you can create, and then you have the data that you can stream somewhere else and filter via this configuration tool file. And this is how it is also the status of the loader during the operation. You have a table, like the one we checked in the previous. I think that the schema is a different. No, TiDB loader. There you go. It just shows the offset of the file that is reading and what is the last position it reads. Boom. All the time is upgrading that because it's doing in bunch of goals. So if the process fails, the next time you fire the process, it will query this table and start over from the last position. The last tool we mentioned in the set of tools, isolated set of tools, is Syncer. And this Syncer is exactly the responsible to keep the streaming from of data from MySQL to TiDB. It can resume data after load is finished because it knows the position, or it also can do anything with the replication coordinates you use. If you have a loaded from a mydumper or a MySQL dump in text files, and you know the position because you have a constant position like Binlogic position or GTID, it can use that position to start replicating data from. It can run per table, per event. It allows very interesting filtering and routing rules. For filtering, you can do, for example, filter by type of command. So a good interesting use case for this is when you have analyticals and you draw or delete all data from your MySQL source. You can instruct the tool to say no, do not delete data from TiDB, so you keep historical data, and it's fine. It will be able to do that. But also you can filter for DBs, for table names, and the common things that we are familiar with. It says it's eventually consistent because the way that it works is that, and this is I'm not sure if it's a limitation or by the same thing. Given there are multiple threads or maybe multiple threads working and applying changes, the data is not guaranteed to be applied in the same order that is in master. So you may, master I mean the MySQL source. So at some point you may end up having, for example, different IDs if you are creating the slips on the TiDB side and stuff like that. Internally, it's highly consistent because all the data is distributed and duplicated into the shards. Let's say in the TiKey, KV nodes. So if a node goes down, the data remains consistent within the remaining of the nodes. So eventually consistent against MySQL. Some examples of the configuration for Thinker. The most important or the first thing you will need to configure is where the data is coming and where the data is going. So you have the MySQL source and you have the TiDB cluster destination. It supports TiDB, it's kind of compatible, and also it supports, I think, TiDB MariaDB version, so it's quite flexible on that regard. Some of the things that Thinker exposes is an interface to check the status, but also it has a error log, so you can both do a monitoring of this situation of how the Thinker is working. So if replication is having problems with lag or the problem with errors in the replication stream, you can monitor that. And also there is a checkpoint table that is exposed when you use the DM worker that I will talk about later in this presentation. So the second tool, or as said before, a grouping of the tools to make all things together, in an easy manner, is the data migration tool, which basically deploys two main components. There is a third, but the two main components are the DM workers, which are created on each MySQL instance you're reading from. One important thing that I didn't mention yet is that Thinker, or the replication, or the cluster is designed at some point to be able to gather data from different sources and collapse everything together. So either you can collapse a table that is sharded in different instances in MySQL. So you can configure and shard everything, the shard sources, and put everything into a single table. So for analytical work, this is very helpful. In this case, we will use different workers on different MySQL sources. Each instance will have its own worker. And then you have the DM master, which is responsible for coordinating things and making things go into the TiDB cluster. Both components expose some interfaces to be able to talk to Prometheus, so you can monitor and keep the statistics of that. And finally, there is the final tool in this group is the DM, or data migration control, which is a client to connect to data migration and do the controlling of operations like start, stop, or whatever you do with the replication things. Here we have another view of how it works internally. Each DM worker will be responsible to execute the mydumper to load the data and the Thinker to keep the replication stream. All of them are coordinated somehow by, I have it put here, this yellow square is the DM master. Is responsible for the coordination of all operations. And if you check, you will see that each worker has a component of mydumper to dump the data, loader to insert the data, and then the Thinker to keep the string going from to the TiDB database. Of course, this is a group of all the things we'll see on the first slide. Again, since it's using Thinker, you still have this ability to skip some things, to configure to avoid replication with some other stuff, and so on. So, yep.
Can you come back?
Yep.
The DM worker is located in which node? Is it in each MySQL node, or is it like an arbitrary node?
No. The DM worker is installed in each MySQL node.
In each MySQL.
Yeah. Then you have the DM master. DM master. I don't remember. Yeah, DM master, which is the responsible to work and coordinate the work among them. Okay. There is no an arbitrator because this is not created for high availability or stuff like that. If the didn't work, stop working, one of your sources won't be available. That's it. So still a lot of effort in monitoring and keep things, under control. But the DM master is responsible to hold this work, and to coordinate this work. Okay,
Thanks.
good. So, and the last of the tools to import the data, this is only designed to import the data. It's called Lightning, sorry. Basically, this is a tool that is created to read a source file, like a mydumper file or CSVs, but it will load everything directly to the TiDB server, so it won't go through the PD server or PD cluster or the TiDB cluster. It goes directly to the storage, so it knows how to send the data and talk directly to the storage. Which makes everything to run super fast because there are no read logs, let's say. It disables some functionalities of the cluster to, so after you load the data, the rebalancing of the data will happen in the background. An important thing is that to make this happening, some of the functionalities are disabled, so in case of an import failure, like, the tool crash, you manually have to set the whole cluster back into the normal mode. It puts the, I don't remember the name, but it puts it creates a mode into the cluster that is import mode, I think. So if the tool fails, the cluster will remain working in that mode, which, as a first symptom, will create slowness in the processing of everything, but also will create a huge spike in CPU utilization. What's the reason? I have no idea. So that's why we say that during this service, the access to the cluster is somehow limited because performance is not the best. So the final part of this is how comparing this tool against other analytical engines and how they do the work compared of how we consume things from the TiDB side. One of the common cases is Cassandra. For Cassandra, you can use Apache Spark. You can use this tool called Stream. I never used that, I know it exists. And Thompson replicators, just to mention some of them. The main problem is that all of these solutions require to create some type of ETL processes to convert the data from a MySQL source into a Cassandra-friendly format. One of the things is that you require some data denormalization, like aggregate data and everything into Cassandra. So it's not straightforward to replicate data from MySQL to Cassandra. It requires some effort, which in TiDB, not really, because it supports like replication string. Clickhouse. Clickhouse is pretty much the same situation. There are some tools, of course. Thompson is some of them, because Thompson supports like streaming everywhere. There is a client to read CSV files and insert into Clickhouse client. And I don't have an example here, but one of my colleagues created some do-it-yourself script for some tricky situations, so I invite you to read the Jeremy real blogs about that. He made a presentation in Propanalite. Still, we're facing the same problem. Data is not fully compatible in the format that Clickhouse or Cassandra requires, so some effort is required. And the final product that can be considered in this situation, there are more, but I'm just checking on this, is MariaDB ColumnStore. Theoretically, it's straightforward because MariaDB has the ColumnStore engine, so it should work pretty much out of the box, which is not fully true because MariaDB requires to drop whatever you have inside to recreate the server with ColumnStore. It requires some specific configurations, and I'm posting here some benchmark that have done by one of my colleagues in Percona, comparing how it behaves or what's the performance of these tools. You know, ColumnStore versus Clickhouse versus Apache Spark. I'm not using this here. I should upgrade this to compare this with TiDB. The main problem I found with TiDB is that you require at least 7 or 8 nodes just to start a cluster, a decent cluster. Or you can grow up because it can scale horizontally to the way that the storage is created. But I should try to eventually do the same test using TiDB and see how this behaves. All in all, the main difference comparing these tools is the capacity that TiDB has out of the box to read MySQL replication without having to do too much manual effort. Oh, okay. So this is pretty much my presentation. Any questions? Yep.
Why I have to use TiDB to do an analysis of data instead of MySQL? What are the advantages?
Wow. Honestly, I haven't found a real use case aside of what they claim to have in the website. But roughly, it's a different product because it has a hybrid design. Like, you know, you have OLTP workload, which is pretty much what MySQL is prepared for, and then you have the capacity for analytical workload because of the way that the data is stored. You know, key value storage is super fast to read big amount of data, which in MySQL is not that good. MySQL doing analytical, you require some, back to one of the slides, data denormalization. You know, you have to aggregate data in MySQL to be able to read. You can imagine if you have to read 6 months of report, you know, of data to create a report which has billions of rows to report in MySQL, that is not performant at all. So you have to do some manual work to aggregate the data somewhere, you know, and create smaller tables to read less rows. Technically or theoretically, TiDB is already prepared for that. I haven't tested myself on a big amount of data. My tests so far are just more functional than any other thing. But the quick answer should be that technically it's prepared for reading much bigger amount of data than MySQL. MySQL actually is not good for analytical work. You know? Yeah.
You said that with 8 nodes you start to see it acting decently, TiDB.
Yeah.
And there is a way to calculate the optimal number of nodes based on load, traffic, whatever. I mean, there is a way to do some kind of calculation and say, okay, you need to have 16 nodes. You need to have...
No, I don't know. When I say decent, I'm talking about at least some level of availability. Because under the need, if you have 2 nodes and you lose 1, you lose somehow quorum. There is a quorum here. Oh, sorry. Yeah. Okay. You have 2, you lose 1. I like to do this.
I know. It's psychological. Oh.
Yeah. Okay.
Okay.
My mind is cheating me. But no, I don't know about the calculation. There should be. I mean, it's not fully optimal to store data. So if you want to handle big amount of data, the amount of nodes required to store the data grows. I'm not sure if exponentially, but even if using RocksDB, which should compress about, you know, and get, you are still doing some internal sharding of data and duplication of data to keep consistency. So I don't have the answer for that, but I wouldn't say that it's cheap to do it. You will require a lot of hardware VM if you are happy to play with.
I was under the impression from some of the stuff that I've looked at with colleagues and things that really the actual hardware, I mean, if you're using it for OLTP type usage, then there's a PD node, so I think it's tiny, because the actual PD node...
PD node, no. It's just, I think it's 3 is the minimum because of the column.
Yeah,
and
but the size of them and the load they have is, relatively speaking, very, 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 very small. So that was what I was the impression I was under.
Yeah, as I said, this is created to scale horizontally, so the more requirements you have, in theory, you have to do a lot of tests still, is to grow up in the storage side, because you will not only have more place to store data, but also you have more concurrency and more capacity to do IOPS. The PD cluster is just to keep some kind of balance between them, and so 3 nodes is fine. I'm not sure about the PD, the TiDB cluster, the facing interface. But if I have to do a quick answer for that, I think that the bigger gains will come from the increasing the amount of nodes in the storage side, TiDB nodes. You're good? Okay. That was it. I hope you enjoyed that. Thank you very much.